Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is the lecture number 34 on the course Applied Artificial Intelligence. Today I am going to discuss about the very important topic, expert system architecture. So these are the topics to be discussed. What is an expert system? What is the architecture of an expert system? The complete module I will discuss, and who are the participants of the expert system. For building the expert system, who are involved? That is what today I will discuss. After the completion of this topic, students can understand students can explain the architecture of the expert system to solve the domain specific problem. This is the topic learning outcome for this expert system architecture. Already I have introduced what is the meaning of an expert system. So expert system, it is nothing but a machine, or it may be a software, or it may be the computer application, which is a specialized branch of artificial intelligence, and they can capture, represent, utilize human expertise to solve complex problems, make decisions, and offer valuable advice. So as I discussed, expert system, it is a system which can give the expert advice to the user like expert people. So how a machine can give the expert advice? So for that, the knowledge should be stored from the expert people inside the knowledge base of the expert system in the form of rules or facts, so that it can understand the problem comes from the user, as well as it tries to solve the problem and produces the result within a fraction of time. This is what the picture, the architecture of the expert system. Total 7 modules are there. This is the first module in the architecture of the expert system. The first module is the knowledge base. Here I have highlighted with red pen because this picture I have captured from the Soros book for artificial intelligence. So this is the first module, knowledge base. Then second module is the inference engine here. Then third one is the knowledge acquisition and the learning module. Then fourth one is the case history. Then the fifth one is the user interface. Then the sixth one is explanation module, and the seventh one is the special interfaces. Let me introduce what are all components. Then I will move to the next slide, and I will show you the contents also. So the first component is the knowledge base. Already I have discussed in my previous video. There are 3 important components of the knowledge expert system. One is the knowledge base. Second one is the inference engine, and third one is user interface. All the 3 components are also available here. The first component is the knowledge base, second component is the inference engine, and the fifth component is the user interface I have mentioned with red mark. So these are the 3 very, very important components of the expert system. During the preparation of the expert system, we need to take care of all these 3 components first. After that, rest all components are optional components, but that is also required. So the first component, knowledge base, the purpose of the knowledge base, as it called as a base. Base means like a database where the data is stored. Same thing, it is called as the knowledge base. Knowledge base is what? Where the knowledge of expert people or the domain expert knowledge are stored in the form of rules or facts or the relationships. Now, inside the knowledge base, it contains 2 types of databases. One is the static database, another one is the dynamic database. I will discuss. Then second component is called as the inference engine. The purpose of the inference engine component is because it interacts with the knowledge base every time. So now inference engine means which can infer the result. That is why the name is called as inference engine. It can infer the result, or it can infer the conclusion by interacting with the knowledge base. That is why it is called as inference engine. And inference engine, it consists of 2 important components. One is the inference, another one is control. That also I will discuss. Next, the third component is knowledge acquisition and learning module. So knowledge acquisition, how the knowledge base will be valid without knowledge. So knowledge acquisition is very important. This is also one of the phase in case of our building the expert system, already I have discussed in my previous video. So knowledge should be acquired from various sources or from domain experts, as well as it should be stored inside the knowledge base. And one more module is there, learning module which can learn or which can update the knowledge if any changes happens further. Fourth component is the case history. So case history, this is for a temporary purpose. Normally it stores all the cases it stores in the form of files which are inferred from the inference engine by interacting with the knowledge base. So case history, it stores all the cases or all the problems in the form of files. Okay. And fifth component is the user interface. So user interface is very important for the interaction or to interact with the expert system, especially it is needed for the layman or the user. That is why one arrow mark is here, it is given. So user, any layman, user, it's not like that. User should have the knowledge of AI, or user should have the knowledge of system. Minimum basic knowledge he or she should have. Then only they can interact with the system and they can access the system also. So that is why for the interaction to the expert system, user interfaces are required. Then sixth module is the explanation module. Explanation module, because it is responsible to provide the explanation for each and every statement. If the user cannot understand, then it can provide in-depth answer. That is why meta knowledge is present in case of the expert system inside the knowledge base. For every information, their further informations or the related informations are also stored. That is why it can able to provide the explanation for each statement to the user. So that is done by the explanation module. And seventh step is nothing but the special interfaces. Apart from the normal user interfaces, some special interfaces are also available in expert system to handle uncertainty. So this is what this is all about regarding this picture. Now let me move forward. Each and every component I will show you. The first one, as I discussed, the first component of the architecture, expert system architecture, is the knowledge base. So knowledge base is considered as the heart or the core module of the expert system. So it is the repository of the knowledge in expert system which stores all the knowledge in the form of facts and rules. And the expert system uses the knowledge to answer the queries or to give the conclusion to the answer. That is why the expert knowledge base is responsible. It contains the domain specific and high quality knowledge. So all the knowledge which are stored inside the knowledge base, that is related to a particular domain or that is related to a particular area. And high quality knowledge means, because the normal we don't gather the knowledge from the normal people. We used to gather the knowledge from the highly experienced people in that particular area. That is why definitely the quality of the knowledge would be high. This knowledge base consists of two important parts or two important databases I have shown in the diagram. So one is the static database and another one is the dynamic database. So as the name it implies, the static and dynamic. Static means which is constant. Dynamic means changing, which can change. Then what is the meaning of the static database and dynamic database with respect to the knowledge base? So static database consists both the databases consist of rules and facts. That is common for both the databases. The thing is, in case of the static database, it consists of the rules and facts or any other form of knowledge representation which may not be compiled, which may be compiled as a part of the system and does not change during the execution of the system. Even the program, even your answers change or anything change, but rules or facts never it is going to be changed. It is fixed for that particular expert system. So static database which consists of the knowledge in the form of rules and facts that are never going to be changed even if your result altered. Okay, so that is nothing but your static database. So compared to the static database, dynamic database consists of facts related to a particular problem asked by the user. That is, dynamic database, as the name it implies, it is a database which is related to the query which is given by the user. So that is like problem specific, right? So at the beginning of the consultation, the dynamic knowledge base is empty, because static knowledge already it would be configured with all the rules and facts, whereas the dynamic database, it is also called as the working memory of the knowledge base, and initially it would be empty. So as the consultation progresses or the work progresses, the dynamic database grows and is used in decision making along with the static database. So working memory, this dynamic database is deleted at the end of the problem or at the end of the consultation of the system. That is why it is called as the dynamic database. The next component, second component, is inference engine. So inference engine is the module which can find the answer from the knowledge base. It consists of two important things. One is the inference engine, second one is the control strategy. What is the meaning of inference mechanism? So inference mechanism means what are the mechanisms are there to infer the result by interacting with the knowledge base. So that is very important for the inference engine as well as the control strategy. Basically, this inference mechanism uses the control strategy, means how the rules can be applied. What would be the order of rules to apply for solving a particular problem. So all these things are this inference mechanism and control strategies should be there inside the inference engine. Now this inference engine, it uses two types of reasoning mechanism. One is the forward chaining, another one is backward chaining. So forward chaining means what? We will move forward, left to right. Okay, so we will try to find out the solution for a particular problem. That is called as forward chaining. But how the problem was solved, like identifying the origin, that is called as backward chaining. Now I will show you with the help of diagram. So this is what the forward chaining is. So it is a strategy of an expert system to answer the question. That means what can happen next. So starting from the original problem, how we are getting the solution. Okay, from the beginning till the end, till the conclusion is called as forward chaining. So this strategy is followed for working on conclusion or result or effect. Okay, so that is forward chaining. For example, the prediction of the share market status as an effect of changes in the interest rate. So this is the diagrammatic representation of the forward chaining. As I discussed, forward chaining is used to find out the conclusion and how would the conclusion we get. So that can be done using the forward chaining mechanism. So here what happens, initially we used to collect all the facts and rules. Suppose fact 1 and fact 2 are merged, and we using fact 1 and fact 2 we are getting one decision, and using fact 3 and fact 4 we are getting one decision. So then decision and decision 2 will be merged, and using decision 1 and decision 2 we are getting the final conclusion. So this is what the problem can be solved. Okay, now you can take the example, any quadratic equation can be solved at a time. We cannot solve at a time. We have to simplify the equation from starting. We will simplify, then we will use the bracket, then after that we will get the answer, and it will take more steps. So that is called as the forward chaining. But how we solve the answer to find out the origin, that is called as the backward chaining. Now this is called as the backward chaining. With this strategy, an expert system finds out the answer to the question, means why this happened, the origin. It tries to find out the origin. So this strategy is followed for finding out the cause or the reason. For example, diagnosis of the blood cancer in human. So here doctor diagnoses the disease. What is the reason why the person has got the cancer? So that is done by the backward reasoning. So this is the pictorial representation of the backward reasoning. Now this is the conclusion already is there, means cancer patient is there. So from this disease, how it was happened, we reached at, the doctor reached at this conclusion that they are the decisions. Then this decision will be splitted. Okay, these are the facts. Because of these facts, this problem happened. So because of this problem happened. So like this, the original, the facts can be understandable or can be identified. So that is called as the backward chaining. The third component is called as the knowledge acquisition. Knowledge acquisition, it is very important. Basically, the quality and the accuracy. These are two important terms, the quality of the expert system and the accuracy of the expert system, how accurately it can provide the result. That depends upon the knowledge which is stored inside the expert system. So how we can say the expert system is a very good expert system? That depends upon the quality and accuracy. That again, this quality and accuracy, that depends upon what type of knowledge it acquires. So knowledge is present in the expert system may be obtained from many sources like the textbooks, the reports, or the case studies, or the empirical data, or the domain experts, which are a prominent source of the knowledge. So knowledge acquisition module source allows the system to acquire more knowledge regarding the problem domain from the expert. Now, the fourth component is the case history. Case history stores the files created by the Inference Engine using the dynamic database and is used by the learning module to enrich the knowledge base, especially the case history. The name is called as history. What it stores, whatever the result comes out from the Inference Engine, that will be formatted. Normally, we used to store in the form, or we used to document our file after the completion of the topic. The same thing, case history, it maintains the document in the form of files which are created by the Inference Engine by interacting with the dynamic database, because dynamic database is responsible to solve or to provide the knowledge for the current ongoing problem. So that is why case history stores the files created by the Inference Engine using the dynamic database and is used by the learning module. So learning module already I have shown with the knowledge acquisition module. One more module is there, that is called as the learning module. It tries to enrich the knowledge base. And the fifth component is the user interface. This is very important. User interface always, it acts as a bridge between the user and the expert system. It provides the interaction between the user and the expert system. And here the user interface may be the menu driven interface, or it may be natural language interface, or any style of interface, or it may be like a graphical user interface or character user interface. The user interface, the user of the expert system need not be necessary an expert. This is very important. The user are the layman like us. It's not like they should be they should have the knowledge of artificial intelligence. They need not be necessarily an expert in the AI, right? They are the layman who will use the expert system to derive the answer. Then sixth one is the explanation module. So this module helps the expert system to give the user an explanation about the expert system, reach to a particular conclusion. It helps to explain the step-by-step approach till the solution. That is why this module is called as how and why. How the problem was solved and why the problem was solved. All the explanations can be given by the explanation module. You can the best example like our ChatGPT. If you ask the ChatGPT, it will give the answer. But if we cannot understand, if we ask explain each statement, it is able to give the explanation of each statement. So that is a kind of expert system which is having the explanation module which can explain each and every step for the user. And the seventh step is the special interfaces, especially they are used for handling the uncertainty in the expert systems. Now let me discuss who are the participants in the development of expert system. These three people are the very important. They are having the very important role for the development, as well as they used to participate in the development of the expert system. First one is the domain expert. Second one is the knowledge engineer, and third one is the knowledge user. Anyways, we people comes under the knowledge user because we don't have any knowledge about the artificial intelligence. Just we are the layman. We want to use the system. So knowledge user, they should not be like the expert engineer. They may not be the domain expert, but they are the layman who are responsible or who wants to use the expert system. And the domain expert means they are not the computer scientists or AI engineers. They are the expertise in their particular domain. They may be a doctor, or maybe a teacher, or maybe a professor, or that depends upon in which area they are experts. So it is not necessary that domain experts are expert in AI. That is also one fact. Another one is the knowledge engineer. This person is very important. Knowledge engineer, who acts as the main important participant in the development of expert system. So especially the knowledge engineer interact with the expert system to acquire all the knowledge, and they used to, knowledge engineers are responsible to store the knowledge inside the expert system, implementation, building of all the components of the expert system. So knowledge engineers are very much important. The role is very important. They should have the knowledge of AI, and they are the AI engineers, we can say. Now let me show you the slides. The first one I told, the domain expert who provides the specialized knowledge and expertise in the specific field, like the medicine or finance or engineering. They can identify the problem solving strategies, rules and heuristics. They collaborate with the knowledge engineers to transfer their expertise into the system. So now domain experts, they should have the knowledge in their field, and they will interact with the knowledge engineer to transfer their knowledge into the system. That is what they are responsible. Second one is the knowledge engineer, who are the main important participant of the development of the expert system. So now the knowledge engineers extract the knowledge from the domain experts and represent it in a structured format suitable for the expert system. That is the first responsibility of the knowledge engineer. They have to collect all the knowledge from the domain expert, and they are responsible to represent the knowledge in the form of rules or facts or relationship or semantic networks or in the form of tree, but in a structured format which is suitable for the expert system. And they are responsible for development and they develop and implement the knowledge base as well as the inference engine. Already I have discussed the component knowledge base development, the designing of the knowledge base along with the static database and dynamic database, and the inference engine, what are the rules are applied, what are the control mechanisms are applied, what are the strategies are required to solve a problem. So all these development and implementation can be done by the knowledge engineers to ensure that the system is accurately reflects expert reasoning and decision making processes. And the third user, as I told, they may not be an expert, but they are the users like us. So end users, they are called as end users also. So end users who interact with the expert system to obtain the solutions or advice, rely on the system to make the decision or perform the task without needing any deep domain expertise. They provide, yes, they can use the expert system as well as they are responsible to provide the feedback on the system performance and usability, which helps in refining the system. So users are the layman. They can use expert system and they can provide the feedback based upon their satisfaction of the result. If they give the positive feedback, then it is well and good. If they give some rectification feedback, then the knowledge inside the knowledge base should be updated. So this is what this is all about regarding for this particular video. For the preparation of this video, I referred this textbook, Soros Kosik for Artificial Intelligence, as well as I have followed these websites which is available on the screen. I hope you might have enjoyed this video. So next class, I will discuss a few more topics on expert system, especially the truth maintenance system, and few list of cells and tools. What are the cells and tools are used to develop the expert system? Those things I will discuss in my upcoming videos. So till then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.